Let us begin our journey by traveling back in time, back millions of years, to when the Earth was a very different place. Picture, if you will, vast forests, warm, shallow seas, and creatures that would seem almost unimaginable today. Birds, as we know them, with their delicate feathers and melodious songs, have a secret written into their very bones. They are the descendants of dinosaurs. Yes, the same dinosaurs that once ruled the ancient world. Around 147 million years ago, in the Jurassic period, certain reptiles began a remarkable transformation. Over countless generations, scales slowly became feathers, powerful legs adapted for running became lighter, built for flight. These were the theropod dinosaurs, creatures like Archaeopteryx, a fascinating animal that bridged two worlds. Archaeopteryx had feathers like a bird, but also teeth like a reptile, and a long bony tail. It represents that beautiful moment in evolutionary time when the age of reptiles was giving way to the age of birds. So when you see a sparrow at your window or hear a robin's morning song, you are witnessing living history. Birds are not merely related to dinosaurs, they are dinosaurs. The only dinosaurs that survived the great extinction that changed our world 65 million years ago. In ancient South America, long after the great extinction, enormous flightless birds, known as terror birds, roamed the landscape. These apex predators stood up to 10 feet tall, with powerful beaks that could crush bone. They were the top hunters of their time, ruling the forests and plains, until the arrival of large mammalian predators. Even today, some birds carry echoes of their ancient past in surprising ways. The hoatzin, a peculiar bird found in the Amazon rainforest, has chicks that are born with small claws on their wings. When danger approaches, these young birds can climb through branches using these claws, much like their distant ancestors might have done millions of years ago in prehistoric forests. These claws disappear as the birds mature, but for a brief window, they offer us a glimpse into evolutionary history, a living reminder of the journey birds have made from the age of reptiles to the present day. Rest now and let your mind wander through those ancient forests where the first birds took flight, carrying with them the legacy of giants. As we continue our gentle journey, let us explore the incredible diversity of the bird kingdom. Across our planet, in every continent, in nearly every habitat imaginable, approximately 10,000 species of birds make their homes. From frozen Antarctic ice to steaming tropical rainforests, from vast oceans to the highest mountain peaks, birds have adapted and thrived. Some birds grew large, while others became remarkably small. Consider the ostrich, the giant of the bird world. Standing up to 9 feet tall and weighing as much as 300 pounds, these magnificent creatures are the largest living birds on Earth. They stride across African savannas on powerful legs, their keen eyes watching for danger across the open plains. At the opposite end of the spectrum is the bee hummingbird of Cuba. This tiny jewel measures just 5.5 centimeters from beak to tail, roughly the size of a large bumblebee. It weighs less than a penny, and yet, despite its diminutive size, it possesses all the complexity, all the wonder of its much larger relatives. Not all birds chose the path of flight. In New Zealand, isolated from the rest of the world for millions of years, many birds gradually lost their ability to fly. Without large predatory mammals, flight became less necessary, and some birds adapted to life on the forest floor. The kiwi is perhaps the most famous of these. This unusual bird has no functional wings at all. Instead, it has evolved into a nocturnal forager, using its long beak and keen sense of smell to probe the forest floor for insects and worms. Its feathers are soft, almost hair-like, and it moves through the undergrowth more like a small mammal than a bird. Penguins, too, abandoned flight, but for a different realm entirely. These charming birds became masters of the ocean. Their wings transformed into powerful flippers, perfectly designed for swimming. Underwater, penguins are graceful and swift, diving deep beneath the waves, pursuing fish with remarkable agility. On land, they walk upright on short legs, waddling across ice and rock in a manner quite unlike most other birds. The isolation of islands like New Zealand created many such flightless wonders. Without the pressure of ground predators, birds could explore new ways of being, new adaptations to their peaceful habitats. The emu of Australia is another large flightless bird, standing nearly 6 feet tall. These gentle giants have 3-toed feet, which provide stability as they walk across varied terrain. They can run at impressive speeds when needed, covering the vast Australian outback with their long strides. Each of these birds, from the towering ostrich to the tiny hummingbird, from the swimming penguin to the forest-dwelling kiwi, represents a unique solution to the challenge of survival. Each has found its perfect place in the grand tapestry of life. Close your eyes and imagine the diversity. 10,000 species, each one a small miracle, each one perfectly adapted to its own corner of the world. Now, let us soar upward into the realm where birds truly excel, the open sky. Flight is perhaps the most defining characteristic of birds, and they have mastered it in ways both graceful and astounding. The albatross is the supreme master of oceanic flight. With a wingspan that can exceed 11 feet, these magnificent seabirds ride the winds above the southern oceans, gliding for miles and miles, barely flapping their wings at all. They have learned to harness the power of wind and wave, using a technique called dynamic soaring. Rising and falling, using the gradient of wind speeds above the ocean surface, an albatross can travel enormous distances with minimal effort. So efficient is this method of flight that albatrosses can actually sleep while flying. Soaring at 25 miles per hour, they rest half their brain at a time, maintaining just enough awareness to keep riding the wind. Days pass and still they glide, sleeping and waking without ever touching down. The swift takes this aerial mastery even further. These small, curved-winged birds are built for continuous flight. During their migration and breeding season, swifts may remain airborne for up to 10 months. They eat while flying, catching insects on the wing. They drink while flying, skimming water's surface. They even mate while flying in brief aerial encounters. Only when it's time to nest do swifts finally come to rest. Vultures employ yet another flight strategy. These large birds are experts at finding and riding thermals, columns of rising warm air. A vulture will spiral upward in a thermal, gaining altitude with barely a wing beat until it reaches cooler air above. Then it glides forward, losing altitude slowly, scanning the landscape below with keen eyes, until it finds another thermal to carry it aloft once more. In this way, vultures can patrol vast territories, searching for carrion while expending very little energy. But not all birds find their mastery in the air. Some have evolved to excel on land. The roadrunner of the American Southwest, that famous cartoon bird, is indeed remarkably fast. These ground-dwelling birds can sprint at speeds exceeding 20 miles per hour. Racing across desert terrain on powerful legs, they hunt lizards, insects, and even small snakes. The roadrunner rarely flies, preferring to use its speed and agility on the ground. The secretary bird of Africa has turned its legs into weapons. This tall, striking bird stalks through grasslands, searching for snakes. When it finds one, the secretary bird attacks with powerful, stomping kicks, delivered with such force and accuracy that it can kill even venomous snakes without being bitten. Its long legs keep its body safely away, while its feet do the dangerous work. The kingfisher demonstrates another kind of mastery: precision. Perched above a stream or pond, the kingfisher watches the water with intense focus. When it spots a fish, it dives, cutting through the air, plunging beneath the surface with its beak perfectly angled, and emerges moments later with its prey secured. This dive must account for the refraction of light and water, judging where the fish actually is, not where it appears to be. The kingfisher performs this complex calculation instinctively, time after time, with remarkable accuracy. From the albatross riding ocean winds for days to the kingfisher's split-second underwater strike, birds have perfected movement in every realm. Let your breathing slow, like an albatross gliding effortlessly, rising and falling with natural ease. Among all birds, few capture our imagination quite like the hummingbird. Let us spend some time with these jewels of the air, exploring their remarkable lives. The hummingbird begins its existence in one of the smallest eggs in the animal kingdom. These tiny white eggs, laid by the smallest species, are no larger than a coffee bean. Often just 2 are laid in a clutch, resting in a nest that might fit in the palm of your hand. This stands in interesting contrast to another remarkable egg. The kiwi of New Zealand, though much smaller than an ostrich, lays an egg that weighs nearly 1/3 of her entire body mass. Imagine the equivalent of a human giving birth to a toddler. The kiwi's enormous egg, relative to her size, is one of nature's most extreme reproductive efforts. But back to our hummingbird, whose adaptations are almost alien in their specialization. The hummingbird's tongue is a marvel of design. Forked at the tip, it extends far beyond the bird's long, slender beak. When a hummingbird feeds, its tongue darts in and out of flowers up to 20 times per second. For years, scientists thought the tongue worked like a straw, but recent research revealed something more fascinating. The 2 tips of the forked tongue curl up, creating a trap, and as the tongue is withdrawn, it brings nectar with it through capillary action. To hover in place while feeding, the hummingbird uses a flight technique unique among birds. Its wings move in a figure-8 pattern, generating lift on both the forward stroke and the backward stroke. The wing doesn't simply flap up and down, but rotates at the shoulder, tracing that elegant figure-8 in the air. The speed of these wing beats is almost beyond comprehension. Depending on the species, a hummingbird's wings beat between 15 and 70 times per second. During courtship displays, when males dive from great heights, the rate can exceed even this. The wings blur into invisibility, creating that distinctive humming sound that gives these birds their name. This hovering ability, this hanging motionless in midair, is achieved by the perfect balance of forces. The wings push air downward with equal force on both the forward and backward strokes. The bird can adjust the angle and speed to move forward, backward, or sideways with precision that rivals even the most advanced helicopter. When it comes time to build a nest, it is the female hummingbird who undertakes this delicate construction. She gathers plant down and soft fibers, binding them together with an unexpected material, spider silk. The elasticity of spider silk allows the nest to stretch as the chicks grow. The outside is camouflaged with bits of lichen, making the nest nearly invisible. Watching a hummingbird build her nest, working with materials that seem almost impossibly delicate, is witnessing natural engineering at its finest. The hummingbird lives life at an extraordinary pace, with a metabolism like a furnace. They must feed every 10 to 15 minutes during the day. At night, they enter a state called torpor, a deep sleep where their heart rate and body temperature drop dramatically, conserving precious energy until dawn. These tiny birds, weighing less than a nickel, migrate thousands of miles. Some fly non-stop across the Gulf of Mexico, 500 miles of open water, with no place to rest. They nearly double their body weight before the journey, building up fat reserves, then burn it all during that single extraordinary flight. The hummingbird reminds us that size is no measure of capability. These smallest of birds perform feats of endurance, strength, and precision that would seem impossible if we didn't witness them every day at our garden flowers. Let us explore now the remarkable senses and intelligence that birds possess. The owl, creature of twilight and darkness, has senses adapted for nocturnal hunting. Its enormous eyes, fixed in place within the skull, gather every available photon of light. To compensate for eyes that cannot move, the owl has been gifted with extraordinary neck flexibility. It can rotate its head nearly 370 degrees, seeing in almost all directions without moving its body at all. This rotation is possible because owls have twice as many vertebrae in their necks as humans. Special adaptations in their blood vessels prevent the blood supply from being cut off during these extreme rotations. The owl can look directly behind itself, then slowly rotate its head, scanning its environment with barely a rustle of feathers. The eagle possesses perhaps the keenest vision in the animal kingdom. From 2 miles away, an eagle can spot a rabbit moving through grass. Their eyes have a much higher density of light-detecting cells than ours, and a deeper fovea, allowing them to resolve fine details at great distances. An eagle soaring thousands of feet above the landscape sees the world with a clarity we can barely imagine. Every movement, every small animal visible against the terrain below. Pigeons, those common city birds often dismissed as unremarkable, possess a sense that seems almost supernatural. They can detect Earth's magnetic field. Within their beaks, they have deposits of magnetite, a naturally magnetic mineral. This biological compass, combined with their ability to detect polarized light, the position of the sun, and even infrasound, allows pigeons to navigate with remarkable precision. A pigeon released hundreds of miles from home can find its way back, using these multiple senses working in harmony. In the caves of northern South America, the oilbird has evolved a sense borrowed from bats. These nocturnal fruit eaters navigate pitch-black caves using echolocation. They emit clicking sounds and listen for the echoes, building a sound picture of their surroundings. Unlike bats, whose echolocation is ultrasonic, the oilbird's clicks are within the range of human hearing, an eerie symphony in the darkness of the cave. When birds gather in flocks, moving as one, wheeling and turning through the sky, they demonstrate another kind of intelligence. Each bird monitors the movements of its neighbors, responding to subtle shifts in position and velocity. The flock moves like a single organism, information rippling through it at astonishing speed. This collective behavior, this murmuration, protects individuals from predators and helps the flock find food. No single bird controls the flock. No leader gives commands. Instead, each bird follows simple rules. Stay close to your neighbors, match their speed, avoid collisions. From these simple individual behaviors, complex collective patterns emerge. Beauty from simplicity. The senses of birds, their intelligence, both individual and collective, reveal minds far more sophisticated than we often appreciate. Behind those bright eyes, sophisticated processing occurs. Senses we cannot imagine guide their daily lives. Rest now. Let your awareness expand, like a bird sensing the world through channels both familiar and wonderfully strange. The term bird brain has long been used as an insult, suggesting someone of limited intelligence. But birds, particularly certain species, would be quite offended by this characterization. Let us discover just how clever birds can be. The African gray parrot, with its soft gray plumage and bright red tail, is perhaps the most famous of avian intellectuals. These birds can learn to mimic over 800 different words, but more remarkably, they don't merely repeat sounds mindlessly. African grays can understand what they're saying. The famous parrot named Alex, who was studied for 30 years, could identify colors, shapes, and materials. He could count. He could understand concepts like same and different, bigger and smaller. When shown an object and asked what color it was, Alex would answer correctly. He wasn't simply trained to give automatic responses. He genuinely seemed to understand the questions and formulate appropriate answers. Research has shown that gray parrots reason at the level of a 4 or 5-year-old human child. They can solve problems, understand cause and effect, and even demonstrate something that looks very much like empathy. In the wild, they form long-lasting pair bonds and communicate with their mates using individualized contact calls. Parrots also have remarkable dexterity. Watch a parrot eat and you'll notice it uses its foot almost like a hand, grasping food and bringing it up to its beak. This zygodactyl foot, with 2 toes facing forward and 2 back, provides an excellent grip. Combined with their curved beak, parrots can manipulate objects in ways few other birds can manage. But when it comes to tool use, one family of birds stands out above all others. Crows and their corvid relatives, ravens, jays, and magpies, are the master craftsmen of the bird world. New Caledonian crows, in particular, demonstrate tool use that rivals that of primates. These crows fashion tools from twigs and leaves, carefully selecting materials and modifying them for specific tasks. They create hooked tools for extracting insects from crevices. They craft spears from leaves. They understand that a short stick can be used to reach a longer stick, which can then be used to reach food. This is multi-step problem-solving, requiring planning and foresight. Young crows learn these skills by watching their parents, and they play with objects, experimenting and learning. They remember human faces and can hold grudges against people who have threatened them. They gather in large groups to mob predators. They hide food in dozens of different locations and remember not only where they hid it, but when, retrieving items in order of perishability. Corvids even seem to understand death. When a crow dies, other crows gather around in what looks eerily like a funeral. They remember dangerous places where crows have died and avoid them. In Australia, the lyrebird demonstrates intelligence of a different kind. This ground-dwelling bird is the master mimic of the bird world. Lyrebirds can reproduce with astonishing accuracy not just the calls of other birds, but any sound in their environment. The whir of a camera shutter, the beeping of a car alarm, the sound of a chainsaw, even human voices. They weave these sounds together into complex songs during their courtship displays. The male lyrebird clears an area of the forest floor, his display ground, and there he performs, his tail feathers spread in a magnificent lyre shape, while he cycles through his entire repertoire of sounds. It can take years for a young male to learn the full range of sounds, practicing and refining, becoming an audio library of his forest home. These birds, with their problem-solving abilities, their tool use, their capacity to learn and remember, challenge our assumptions about intelligence. The bird brain, it turns out, is an impressive instrument indeed. Let your mind rest, appreciating the many forms that intelligence can take. Birds fill our world with sound. Let us listen to the remarkable ways they communicate. Even the humble chicken, familiar farm bird, has a vocabulary that would surprise most people. Chickens produce over 200 distinct vocalizations. They have different calls for different predators, an aerial alarm for hawks, a ground alarm for foxes. They make contentment sounds while dust bathing. They have calls that tell chicks to hide, calls that announce food, calls that maintain flock cohesion. Mother hens even communicate with their chicks through the shell before they hatch. But for sheer volume, no bird can match the white bellbird of the Amazon. The male bellbird's call, delivered during courtship, reaches volumes of over 125 decibels. This is as loud as a thunderclap or a rock concert. The female, remarkably, perches right next to the male during these deafening displays. How her hearing survives remains a mystery. The white bellbird holds the record as the loudest bird call ever measured. Some birds create sound through unusual means. The snipe, a wading bird of wetlands and meadows, produces an eerie winnowing sound during its courtship flight. As the snipe dives through the air, it spreads its tail feathers. Wind rushing past these specialized outer tail feathers causes them to vibrate rapidly, creating a haunting, trembling whistle that carries across the marshland. It's not a vocalization at all, but an instrumental performance played on feathers. Even birds we think of as ungainly have their own forms of communication. The flamingo, that pink wading bird, feeds in a most unusual way. It holds its head upside down in shallow water, sweeping its specialized beak back and forth. Inside the beak, comb-like structures filter tiny organisms from the water. This upside-down feeding is unique among birds. What makes flamingos pink is not genetics, but diet. They feed on algae and small crustaceans that contain carotenoid pigments. These pigments are absorbed and deposited in growing feathers, turning them various shades of pink or coral. A flamingo eating a diet without these pigments would gradually fade to white. Their color is a direct reflection of the richness of their feeding grounds. Flamingos are also surprisingly vocal birds. A flamingo flock is a noisy place, filled with honking calls. Each flamingo has a unique voice, and parents and chicks can recognize each other by sound alone. In a colony of thousands of nearly identical pink birds, a parent returning to the nesting ground will call out, and its chick will answer, and through this exchange of voices they find each other. Sound for birds is connection. It is identity. It is attraction and alarm, comfort and warning. Every dawn chorus, with its layered melodies, is a conversation. Birds announcing their presence, defending territories, seeking mates, checking in with flock members. The soundscape of birds is a language of remarkable complexity, one we are only beginning to understand. Let the sounds of nature, the calls of birds, distant or remembered, create a peaceful background as you drift deeper into rest. In the world of birds, beauty serves a purpose. Courtship displays, elaborate plumage, these are the language of attraction. Let us witness some of nature's most spectacular performances. In many bird species, it is the males who wear the brightest colors. Vivid plumage signals health and vitality, advertising genetic fitness to discerning females. A male who can afford to be conspicuous, who can carry the burden of bright feathers that might attract predators, demonstrates his strength and capability. The frigate bird of tropical oceans takes this to extremes. The male frigate bird has a red throat pouch, which normally lies flat and invisible. But during courtship, he inflates this pouch into an enormous balloon, bright scarlet against his black plumage. Perched on a branch, with his pouch inflated, the male frigate bird throws his head back, spreads his wings, and calls to females flying overhead. The display is impossible to ignore. The bowerbird of Australia and New Guinea practices artistry. Male bowerbirds build structures, called bowers, from sticks and grass. These are not nests, but courting grounds. Some bowerbirds build avenue bowers, parallel walls of sticks creating a corridor. Others build maypole bowers around a central sapling. But the structure is only the beginning. The male bowerbird then decorates his bower with blue objects, flowers, feathers, berries, even bits of blue plastic or glass. He arranges them carefully, creating a display. Some species even paint the interior walls, using crushed berries or charcoal mixed with saliva. When a female visits, the male performs an elaborate dance, presenting his decorations, maintaining his gallery with meticulous care. The manakin, tiny birds of Central and South American forests, have turned courtship into synchronized performance. Males gather at display grounds called leks. Some species perform solo, but others have learned to dance in partnerships. Two males, coordinating their movements with split-second timing, leap and flip, creating a display that looks almost choreographed. They take turns, each supporting the other's performance, all to impress watching females. In the cloud forests of Central America, the resplendent quetzal displays its magnificent tail plumes. These iridescent green feathers, longer than the bird's entire body, shimmer with color that shifts as the bird moves. The quetzal was sacred to ancient Mayan and Aztec civilizations, and it's easy to see why. In dappled forest light, these birds seem to glow with an otherworldly beauty. The motmot, another Central American bird, has an unusual relationship with its tail feathers. Young motmots have full tail feathers, but they deliberately trim them, preening away the barbs on sections of the two central tail feathers. This creates a bare shaft with a racket-shaped tip at the end. Why they do this isn't entirely clear. It may enhance their courtship displays when they swing their tails back and forth, those racket tips making them more visible. The sunbittern of tropical American forests normally appears quite understated, brown and beige with subtle patterning. But when threatened or during display, the sunbittern spreads its wings, revealing a dramatic pattern of orange, red, and black, arranged in circles like great staring eyes. This sudden transformation, from cryptic to conspicuous, startles predators and attracts mates. Each display, each color, each dance and decoration represents the investment birds make in the continuation of their species. Beauty in nature is never merely decorative. It serves purpose. It carries meaning. It speaks a language older than words. Rest now, and dream perhaps of bright feathers, of colors beyond naming, of nature's artistry. The care that birds give to their young varies wonderfully across species. Let us explore the many ways birds ensure the next generation survives. The weaver birds of Africa are master architects. Males weave intricate nests from grass and palm fronds, creating hanging structures with entrance tunnels. The male weaves the nest entirely by himself, working for days, carefully knotting and threading each piece of vegetation. When complete, the nest hangs from a branch, swaying in the breeze, safe from climbing predators. The male then calls to females, displaying his creation. If a female approves, she will line the nest and lay her eggs there. If she rejects it, the male must start over. Sometimes dozens of nests hang from a single tree, the work of multiple males, each hoping to attract a mate. Hornbills employ one of the most unusual nesting strategies in the bird world. When a female hornbill is ready to lay eggs, she enters a tree cavity. Then, with help from her mate, she seals herself inside. Using mud and droppings, they wall up the entrance, leaving only a narrow slit. The female will remain imprisoned in this cavity for weeks or even months, completely dependent on the male to bring food. During this time, she molts all her flight feathers at once, growing new ones in the safety of her sealed chamber. She lays her eggs and cares for her chicks. The male brings food to the slit, passing it through to his family. This strange arrangement protects the vulnerable female and chicks from predators that couldn't breach the sealed entrance. Not all birds are devoted parents. The cuckoo, infamous for its deception, practices brood parasitism. A female cuckoo watches other birds, waiting for them to leave their nests. She swoops in, lays a single egg, and departs. She never builds a nest or cares for her young. Instead, unsuspecting foster parents, often much smaller birds, raise the cuckoo chick as their own. The cuckoo chick hatches early and often pushes the other eggs out of the nest. The foster parents, exhausted, work tirelessly to feed the giant chick, which may grow much larger than they are. It's a harsh strategy, but remarkably successful. The sand grouse of African and Asian deserts faces a different challenge. Living in arid environments far from permanent water, how do chicks survive? The sand grouse has evolved a remarkable solution. His belly feathers are specially adapted to hold water, like a sponge. Each day, the male sand grouse flies to a water source, sometimes many miles away. He wades into the water, soaking his belly feathers completely. Then he flies back to the nest, where the chicks drink from his wet feathers, getting the moisture they need to survive. The shoalfens, ground-dwelling birds, incubate their eggs not with body heat from sitting on them, but by burying them in carefully constructed mounds of vegetation. The decomposing plant matter generates heat, maintaining the perfect temperature for the developing chicks. The male shoalfen monitors the mound constantly, adding or removing material to regulate temperature, becoming a living thermostat. Penguins in the frozen Antarctic face perhaps the harshest nesting environment on Earth. Emperor penguins breed during the Antarctic winter in temperatures that can drop to -50 degrees. The male carries the single egg on his feet, covered by a fold of skin, keeping it warm through months of darkness and brutal cold. Hundreds of males huddle together, sharing body heat, rotating from the cold exterior to the warmer center of the huddle while the females are away at sea feeding. Each strategy, each adaptation represents a solution to the challenge of raising vulnerable young in a world full of dangers. The diversity of parenting strategies reminds us that there are many paths to the same essential goal: continuation of life. Let yourself rest, secure and warm, like a bird in its nest. Birds have evolved remarkable strategies for finding and capturing food. Let us observe some of the most ingenious feeding techniques in the natural world. The phalarope, a small shorebird, has discovered a clever way to bring food to the surface. Landing on water, the phalarope begins to spin rapidly, creating a small whirlpool. This vortex draws tiny prey items up from below, concentrating them where the bird can easily snatch them. Around and around, the phalarope spins like a tiny feathered ballerina, creating its own buffet. The black heron of African wetlands uses a different technique. This bird hunts in shallow water, and when it spots a likely fishing spot, it spreads its wings forward, forming a complete canopy over its head. Standing motionless, the heron creates an umbrella of shade on the water. Fish, seeking shelter from the bright sun, swim into this shadow, and there they meet the heron's beak, striking with precision from within the darkness. Not all birds of prey eat meat. The palm-nut vulture, despite its name and its membership in the vulture family, is largely vegetarian. These birds primarily eat the fruit of oil palms, supplementing their diet occasionally with fish or carrion. But fruit makes up the vast majority of what they eat. It's a surprising dietary choice for a bird that looks like a fierce predator. The frigate bird, a magnificent seabird with deeply forked tail and angular wings, has earned a reputation as a pirate of the skies. While frigate birds can catch fish themselves, they often prefer to steal meals from other birds. They chase boobies and other seabirds, harassing them in mid-flight until the frightened bird drops or regurgitates its catch. The frigate bird then swoops down, catching the stolen meal before it hits the water. This behavior, called kleptoparasitism, is faster and less energy-intensive than fishing, at least for a bird skilled at aerial pursuit. In the forests of Central and South America, puffbirds employ the strategy of patience. These birds perch motionlessly, sometimes for hours, watching for insect movement. When prey finally appears, the puffbird launches from its perch, snatches the insect from the air or from foliage, and returns to wait again. This sit-and-wait hunting requires patience, but conserves energy. The bird moves only when success is likely. Their relatives, the nunbirds, use a similar strategy but from the shade. They perch in shadow, darting out into sunlight to catch flying insects, then returning to their shaded perch. The contrast between light and shadow may help them spot prey, or perhaps the shade simply keeps them cooler during long hours of hunting. The limpkin, a large wading bird of American wetlands, has specialized in eating one particular type of prey, freshwater snails. Its long, curved bill is perfectly adapted for this task. The limpkin probes in bud and vegetation, feeling for snails. When it finds one, it extracts the soft body from the shell with practiced movements of its specialized bill. The limpkin's entire lifestyle, its habitat choices, its behavior, centers around this single food source. Each bird has found its niche, its particular way of extracting energy from the environment. Some spin water into vortexes, some create shadows to lure prey, some steal from others, some wait with infinite patience. The variety of feeding strategies reflects the variety of opportunities that exist in nature. Let your breathing become slow and regular, like a patient hunter, waiting, calm, at rest. As we near the end of our journey, let us meet some of the rarest and most unusual birds. Some bring us wonder, others remind us of the fragility of life on Earth. The Madagascar pochard, a diving duck, was thought to be extinct. For 15 years, no one saw a single bird. Then, in 2006, a small population was discovered. Fewer than 25 individuals remained. Through intensive conservation efforts, carefully managed breeding programs, the species clings to existence. But its status remains precarious, a reminder of how close we can come to losing something forever. At the other end of the spectrum is Wisdom, a Laysan albatross, who represents the remarkable longevity birds can achieve. Wisdom is over 70 years old and still breeding. She was first banded as an adult in 1956, which means she was at least 5 years old then. Every year she returns to the same nesting site on Midway Atoll. She has raised dozens of chicks in her long life. She has flown millions of miles, circling the Pacific Ocean, riding the winds that albatrosses know so well. Wisdom reminds us that individual birds are not just representatives of their species, but individuals with their own long stories. She has lived through enormous changes in the world, and still she flies. Still she nests, a connection to the past, continuing into the present. Some birds have evolved in ways that seem almost alien. The jacana, also called the lily trotter, walks across floating vegetation on lakes and ponds. Its toes are extraordinarily long and widespread, distributing the bird's weight so it can walk across lily pads without sinking. Watching a jacana step delicately across a pond surface, looking for insects, is like watching a bird walk on water. The siriema, a large terrestrial bird of South American grasslands, has an unusual way of staying safe. When it senses danger or simply wants a better view, it leaps straight up into the air, sometimes 2 feet or more. From this aerial vantage point, it can scan the grassland for threats. Then it lands and continues on its way. It's an unexpected behavior from a bird that seems built for running. And finally, let us end with a gentle mystery. The chicken, most familiar of birds, carries a curious correlation in its genetics. The color of a chicken's earlobes, those small patches of skin below the ear opening, predicts the color of the eggs it will lay. Chickens with white earlobes lay white eggs. Those with red or brown earlobes lay brown eggs. It's a connection that seems arbitrary, yet holds true with remarkable consistency. Even in something as familiar as a chicken, nature keeps small surprises. These are the birds of our world, from the smallest hummingbird to the tallest ostrich, from the depths of time when birds were dinosaurs to the present day where they fill every corner of the globe. Some common, some rare, some mysterious, some familiar, but all of them remarkable. As you rest now, perhaps you'll dream of flight, of soaring over oceans, of forests filled with song. The world of birds is vast and wonderful, and it shares our planet with us, filling it with color and sound and endless surprise. Let these images fade gently as sleep takes you into peaceful darkness, safe, warm, and still. Rest well.